Hello everyone. So today we're going to be working with Lewis structures again, but this time with multiple bonds. So our first example will be CH2, CH2. Same as before, we want to first count the total number of electrons. So with 2 carbons, we'll have 8. And from the 4 hydrogens, we'll have 4. A total of 12 electrons. So let's start with the carbon framework. Each carbon with 4 valence electrons. Next, we'll bind 2 hydrogens to each carbon. As you can see now, the problem is that neither carbon has an octet. Each has 7 electrons. And in order to fix this problem, we can take 1 electron from each and create a double bond. So we'll do that by putting 4 electrons between each carbon, as well as bonding 2 hydrogens to each. Now, if we count the total number of electrons, we have 2, 4, 6, 8, 10, 12 total electrons, just as we expected. This structure can also be drawn as this. Alright, our next example is going to be CH3, CO, CH3. So again, let's start by counting the total number of electrons. 3 carbons will give us 12 electrons. 1 oxygen will give us 6 electrons. And 6 hydrogens will give us 6 electrons. A total of 24 electrons. So let's start with the carbon framework. And then we'll bond 3 hydrogens to each of the terminal carbons. 1 here, 1 here, 1 here, and then 3 to this carbon as well. Now, we need to bond an oxygen. An oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. So the problem again is that now neither the carbon in the middle or the oxygen has an octet in this situation. However, if we use this lone electron here and this lone electron there and create a double bond between carbon and oxygen, we'll fix this problem. So we'll do that as shown. CH3, CH3, double bonded to oxygen, and oxygen maintains those 2 lone pairs that it had before, here and here. Now, just to be sure, let's count the total number of electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Just as we expected. So this would be the stable Lewis structure for this molecule. Alright, our next example is going to be CH3, CNH, CH3. So as we've done before, we'll first count the number of electrons. 3 carbons giving us 12. 7 hydrogens giving us 7. And 1 nitrogen giving us 5. A total of 24 electrons. So as we did last time, we'll start with the carbon framework. 3 carbons. And we'll bond 3 hydrogens to each terminal carbon, as seen in the chemical formula. And now we need to bond a nitrogen to that interior carbon. We know nitrogen has 5 valence electrons, so 1, 2, 3, 4, 5. And then it also has a hydrogen bound to it. The problem here, as in the last example, is that now carbon nor nitrogen have an octet. To fix this, we'll use the unpaired electron here and the unpaired electron here to create a double bond between carbon and nitrogen. We'll draw that as shown. CH3, C, CH3, double bonded to nitrogen, which is bonded to hydrogen, and nitrogen is going to maintain the lone pair that it had here. Now to be sure, let's just check the total number of electrons again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 24 electrons as we expected, so this would be the stable Lewis structure for this molecule. Lastly, here are some practice problems you can do to take into class. These will give you a good understanding of how well you know the material. Good luck.